Okay, as we get into triangles, we're going to deal, and if you actually taught a geometry class, you would deal a lot with right triangles, the relationships within them. You would introduce the special right triangles. You would introduce um, right triangle trig, stuff like that. And the Pythagorean theorem is a huge part of that part. So we're going to take a moment in lesson 6 and go over everything the Pythagorean theorem can do. All right, so the Pythagorean theorem is used to find the missing side of a right triangle. All right, sides A and B are called legs, and side C is called the hypotenuse. And for any right triangle, a squared plus b squared equals c squared is your Pythagorean theorem. And there is several proofs for the Pythagorean theorem. Depending on your students, this might be helpful for them to really understand. There's a video in Canvas that also walks through it. Some of the proofs are complicated. Some of them are pretty straightforward. The one in the video is actually pretty straightforward as well. Now, for any right triangle, a squared plus b squared equals c squared. All right, so this also kind of implies that Pythagorean theorem only works for right triangles, meaning that if the Pythagorean theorem works, then you must have a right triangle. Okay, so you can also use the Pythagorean theorem to see if the side measurements produce a triangle or not, and if they do, what kind is produced. So if a squared plus b squared equals c squared, then it is a right triangle. But what if c squared is greater than a squared plus b squared, or less than a squared b squared? Well, as you can see here, if c squared is equal to the sum, then it's right. If c squared is greater than the sum, it's obtuse. If it's less than the sum, it's acute. Now, whether it produces a triangle or not, here's how you know that. The two sides, or the two shorter sides, have to add to be more, than the third side. Okay, so if they do not add up to be more than the third side, then you end up with something that looks like this, where there's just a third side that's too short, doesn't complete the triangle. So the two shorter sides have to add up to give you a sum that is bigger than the third side. If that's true, you have a triangle, and then you have to figure out what kind of triangle. If it's not true, then you don't have a triangle at all. Okay, so for number one, we're just going to figure out, also with these three equations, keeping c squared on the left really keeps you from having any confusion about what's going on. All right, so for the first few, we're just going to look at, the first four problems, we're just going to look at Pythagorean theorem and how to use it. All right, so x is on my hypotenuse, so I got x squared equals 8 squared plus 13 squared. Okay, so you have, let's see, x squared equals 64 plus 169. X squared equals 233. So when I take the square root, x equals the square root of 233. And it says round to the 10th. So that's one decimal place. So that's going to be approximately 15.3. Okay. Now, sometimes it makes sense to leave it in radical form. Sometimes it doesn't. So it really depends on what Pearson's asking for, or if you have more steps in the problem to go. And I say that because if you round too early, that can present a rounding answer in your final answer if you have multiple steps to do. On number two, x is one of your legs, so it doesn't matter which leg you let it be. You got x squared plus 7 squared equals 9 squared. So x squared plus 49 equals 81. X squared equals 32. So x equals the square root of 32. And if we're rounding to one decimal place, that's going to be 5.7. Now, this square root is also a root that you can simplify. So there is a 4, or sorry, there's a 16. 16 times 2 is 32. And you can take square root of 16. So if you did that, that would be the 4 square root of 2. So simplifying a radical is totally acceptable. It leaves it in exact form, but it just gives you a simplified version. But again, it depends on what Pearson's asking for, and if they ask for decimal, it's going to be 5.7. Right? Now, on 3, this is an isosceles triangle because the two sides are the same. And if the two sides are the same, then this dotted line right here splits this base in half. So this is going to be 11. This is going to be 11. All right, and so this is going to be x squared plus 11 squared equals 24. Okay, sorry, 24 squared. All right, so x squared equal, or I'm getting ahead of myself, plus 121 equals 576. X squared plus, x squared equals 576 minus 121 is 455. So x equals the square root of 455. And the decimal to one place is going to be 21.3. Right? So that's that. Now, 4 is an application problem. It says a roofer leans a 16-foot ladder against a house. Right, so go ahead and draw a right triangle. "16-foot ladder." All right, if the base of the ladder is 5 feet from the house, all right, so this is the vertical side right here is going to be your wall. So the base is going to be 5 feet. All right. Some students get really freaked out if you don't draw the triangle even somewhat to scale. So let's redraw that. 16 feet. This would be 5 feet. And then how high up the ladder, how up the house does the ladder reach? So I'm looking for this right here. So draw your picture, set it up, and that kind of indicates to you how your Pythagorean theorem should be set up, which side is missing. All right, in this case, it's one of the legs, so you got x squared plus 5 squared equals 16 squared. Solve it down, you get 25 equals 256. X squared equals 231. So x equals square root of 231. And if we're following the same rule as before, the one decimal is going to give me 15.2. And because we're dealing in feet, make sure you include your units. Okay. All right, determine if the side lengths produce a triangle or not. Remember that the two shorter sides have to add up to give you more than the third side. So on 3 plus 7 are the two shorter sides. 3 plus 7 is 10. So 3 plus 7 is greater than 9. So this is going to be a triangle. 20 plus 21 is greater than 29. So this is going to be a triangle. On 7, 4 plus 11 is less than 16. So this is not a triangle. All right, and then on 8, 31 plus 35, it's greater than 39. So this is going to be a triangle. So we need to figure out what kind of triangles those are. But number 7 is not going to be a triangle for the reasons we mentioned. All right, now that we know there's going to be a triangle, we need to set this up. Remember, c squared is your bigger side, your hypotenuse, and we want to put that on the left. All right, so this is going to be 9 squared, colon, 3 squared, plus 7 squared. And then we're going to solve each side and see, are they equal? Is 1 less than, greater than? All right, and we're going to keep the colon in the problem until we know exactly what's going on. So this is going to be 81, 9 plus 49. All right, 81. 9 plus 49 is 58, and 81 is greater than that. Well, if c squared is greater than, then that means this is an obtuse triangle. All right, number 6, do the same thing. 29 is the biggest side, so you get 29 squared equals, or colon, 20 squared plus 21 squared. 29 squared is 841. 20 squared is 400. 21 squared is 441. So 841 equals 841. And since one side equals the other, this is a right triangle. Okay. On 8, we got 39 squared, colon, 31 squared plus 35 squared. All right, 39 squared is 1521. 31 squared is 961. 35 squared is 1225. I'm not expecting you to know these off the top of your head. I've already done these in my calculator. So feel free to use your calculator to do this. 1521, 961 plus 1225 is going to be 2186. And 2186 is bigger than 1521. So c squared is less than, which means this is an acute triangle. All right, so that is it over the Pythagorean theorem. Hope you got something out of it. Remember, as a teacher, this is going to be a huge help for you if you teach geometry or even basics of geometry, like in middle school and stuff like that. So, all right, I will see you in the next lesson.